Hey guys, Sharpsheen1 here again with another Roblox scripting tutorial. Today I'm going to do part 2 of the BodyMovers subject. Today the BodyMovers we're going to go over are BodyThrust, BodyVelocity, and BodyAngularVelocity. So let's go ahead and open up Roblox Studio and go to a base plate. So first, just like yesterday, we need to get a part to apply the forces to. And then the first one we're going to go over is BodyThrust. So insert it into the part, and then BodyThrust is pretty much the exact same thing as BodyForce, which we went over yesterday, except that with BodyThrust you can choose what position or what part of the part you want to apply the force to. So they're the same properties in BodyThrust, except there's one extra property called location. Now this is not where the part is trying to get to. This is the offset from the center of the part that the force is being applied to. So the force works the exact same way as it does in the body force, but the location is the offset on which the part is being placed, which the velocity is being, or the force is being placed on. So the center of the part should be right between those four dots right there, and so that's where the force is being applied to currently. But if we if we apply, so let's say on the x-axis we do 1 and press enter, then the force is going to be applied one step away from that. So the force should be applied to around here right now. So let's apply an upward force to that. So let's do like 800. And let's also make sure these surfaces are smooth so it does not snap onto the base plate. And so now let's play. So what should happen when we play this is that the part should pretty much flip over because the force is being applied on near the end of the part. So it should push it up, but then it should flip it over because the force is not evenly centered. See, as you can see right there, the force flipped it over, and now that it's upside down, it can't spin that direction anymore because it's facing down. It's doing that as much as it can. So you can, let's see. So you could do it from like on the z-axis too. Go upwards like that near the other side of it. That would flip it over the opposite way, so we'll do it like that. So as you can see, it's flipping it over now. And I'm not sure what it will do if you increase the y-axis, since it's only one stud high. But let's see what it does. I think it'll just still go up. Oh yeah, that's right. It didn't go up. Maybe we need to increase the force. So I think the reason why it's not going up is because I made the location in which the force is being applied one stud above the center, and since this part is only one stud high and the center is in the middle of that, then the force is being applied somewhere up here, which is where no part is. So that's possibly why it's not doing anything. It's applying force to nothingness. So I think if we do 0.5, that should be right at the top of it. Maybe that'll push it up as well. Oh, that didn't do it either. So maybe let's change it back to 0. I didn't go up either. Let's try 2000. There we go. So just like yesterday, BodyThrust would be programmed pretty much the same way as you would with BodyThrust would be programmed the same way as body force, except that you would just have to offset the location if you needed to. So that's it for BodyThrust. Body force and BodyThrust are very simple body movers. And so now we're going to go on to BodyVelocity. So BodyVelocity is the body mover that I use most often. It's pretty similar to the body position one. It has except it does not have a dampening property. It has max force, P, which is, as we went over yesterday, is aggressiveness, and we also have velocity. So with body velocity, because we have a max force property, we do not have to make the velocity high numbers in order just to get it to move off the ground. And with body velocity, if we have the max force high enough, we can use the velocity thing as the direction we're going to and basically the speed, because we do not have to have large numbers just to get it to move off the ground. So the thing you're most likely going to want to have the body velocity set to is infinity, which is going to be math.huge. So let's try to do the look vector thing again. So we're going to get the front surface, so we can kind of get an idea of where it's going to go, and then let's make it motor. So that's the front surface right there. So let's do a script. So I gotta set some properties of it. We're gonna leave the aggressiveness the same. We're gonna change the max force and the velocity. So what I'm gonna do is that, since I was talking about the velocity, we can use that as a speed and a direction. We're gonna have to multiply the direction of the velocity, which is the first thing we're gonna set it to. So first we're gonna set the velocity, the direction, and then we're gonna multiply it by a speed that we want. So let's make a variable called speed. Let's do 12. And then let's set the max force to infinity. So we're going to do script.parent.maxForce equals vector3.new, because it's vector 3 because we are defining how much force can be applied on all the axes, and we want it all to be the same. So we're going to do math.huge to represent infinity for all of the axes. So math.huge, math.huge, math.huge. And then we're going to do the velocity part. Since we're trying to get it to go in a specific direction, which is the direction the part is facing, what we're going to do is we're going to do script.parent.velocity equals script.parent.parent, which is the part, .cFrame.look vector. So that gets us the direction that it's going. And to get the speed, we're going to multiply it, which is that little star right there, times speed. And so there it goes. So that's cool and all, but what if we possibly wanted to change direction sometimes? Well, what we can do is that, since if we wanted to keep it going on that on the way it's facing, we just gotta change the way it's facing. So that is where body angular velocity can come into. So let's see. There we go. So go ahead and insert that into the part as well. And so it has the same properties as body velocity. It has max torque and the P, which is aggressiveness, but instead of velocity, it has angular velocity. So body angular velocity, what it does not push a part forward or any actual direction. What it does is it applies a force to rotate the part. So this can be very useful for things like cars or something like that. So because you can put some angular velocities in it to change which way the whole car is facing. So let's put a script into this one as well. And so what we're going to do is we're going to have this part constantly changing its direction or constantly turning. Basically, we're just going to have it go in a circle. So we're going to have it spin in a circle. So what we're going to do is we're going to do an infinite while loop. So to do that, we're going to do while, and then to show how much time there's going to be between each loop, we're going to do wait 0.01. And we're going to do. And just to let you know, if you do an infinite while loop, you have to have some kind of wait or some kind of function that includes a pause inside of it. Because if you do not, it's going to loop super fast, and then it's going to end up crashing your entire studio. And if it's a game server, it's going to crash the entire server. So you don't want to let it loop infinitely without some kind of wait in between. So what we're going to do is that we're going to increase the angular velocity every time. So actually, before it goes into the while loop, we got to set the parameters of the body angular velocity. So we're going to adjust the max torque. So script.parent.max torque. It is still a vector 3 value. We're going to make it we're going to use math.h to represent infinity on each of the axes. There. So now what we're going to do is we're just going to increase the velocity. Well, actually, wait, no, I'm sorry, I was wrong. I don't need to. We don't need to do a while loop, because what it's going to do is it's going to apply that force forever until the force becomes 0 again. So we don't need a while loop. That was pretty stupid of me. So we're going to do script.parent.AngularVelocity equals vector3.new. So before I go into choosing the axis that I'm going to spin the part on, I'm going to explain something. So you may think that I don't know, you may not think this, but this is kind of what I thought at the beginning. You may think that because like if you increase the velocity on the x-axis, you may think the part is going to spin in this direction, because that is the way that the red arrow is pointing when red one is X and the blue one is blue. So you may think that it's going to spin that way because of the way that arrow is pointing, but that is incorrect. So the best way to represent how these rotations are going to work is by getting this, as I click on the part and then getting your move tool. So picture these arrows going through the part completely, and picture these as the axles these things are going to spin on. So if we want it to spin in this direction, like in a circle like this, then we're going to have to rotate it on the y-axis, because if we're going to have the part spinning on this thing like the axle, as if you had a hole in this thing and this rod was going through it, if you were to try to spin it, it would only spin in the circular direction. It's going to spin around this rod right here. And it's the same way with the x and the z axis. So if you have a rod going through the part this way, then it's going to rotate this way like that, or the other way around, depending on how the force is being applied. And the same with this with the z axis as well. It's going to spin this direction, because that is the way that the axles go on through it. So I just thought I should clarify that first, because I didn't completely understand that when I first started learning about this stuff. So since we're just gonna have it spin in a regular circle like this, so we're gonna have to spin it on the y-axis. So we're gonna apply. Let's see. So we're gonna do 50. And by the way, we don't have to worry about kind of like the direction it's going to move. This basically we're just finding the speed that it's going to spin on in the axis, and the axis that we apply the force to tells us which which direction it's going to spin in. So basically, just putting numbers in these axes for angular velocity, it's just telling you how fast it's going to spin. So now that we have these two scripts working at the same time, this one is gonna keep applying force in its look vector, and this one is going to keep spinning. So let's see what it does. So as you can see, this thing isn't really changing the direction it's moving at all. This one is still going in the same direction, but it is still spinning a lot. So what we do need, so what happened is this one keeps spinning, which is this script is doing exactly what we want it to do, but this one isn't. So the reason why it's not changing its direction at all is because we told this velocity isn't going to change at all, because we only set it once. So we set it to the look vector it was when the game first started. But we didn't update with the look vector at all. Like the look vector is still updating on the part, but we are not looking for that different look vector, so it's not going to go anywhere else. So in this script, this is the one where we're going to have to put a while loop in. So what we're actually going to do is that we're going to do it every time a frame renders. So to do this, we need to get this service in Roblox called run service. So we're going to make it represented by the variable run. And so we're going to do run equals game get service run service. So now every time that a frame goes by, which is like every time something changes, like, so right now if I were to hold everything still, no frames are passing me because nothing is moving at all. But if something moves even a little bit, then a frame passed. All right. So right now a bunch of frames are passing right now because something is being moved. So that is kind of how it works. Kind of brief description, but that's basically how it works. So what we're going to do is that run.renderStepped connect function. And the renderStepped function event does not pass any parameters, so we don't have to worry about any of that. Alright. Whoops, we need to do that. I believe. Yeah, that's right. Okay, so now let's go ahead and try this again. Actually, we're going to make this a bit slower because we saw earlier it was spinning pretty fast. We put that to 20 instead. So now let's press run and see how it does. Now it's not going in that same direction, but it isn't really moving anywhere because since it is spinning so fast, it's moving in the direction it's going, but then it turns so fast it goes in the other direction. So it's kind of trapping itself. So the way to solve this is to lower how fast it's going to spin. So let's put it to 5 again, I suppose. There we go. See, it's still going in a circle, but it's going in a bigger circle. So if we wanted to go even a bigger circle, we could do like maybe 0.5. There we go. See, now it's going in a pretty big circle here, because it's turning so much slower, and every single frame every single frame is going in the new direction that it finds. Okay, so that's fine and dandy, you know. So, using some of the forces that I gave you guys, I'm actually gonna do something kind of cool. So, actually, we're gonna use we're gonna use body position for this one. I think it'd be better if we did body force or something. Okay, we can figure it out soon. So what we're gonna do is we're gonna have two platforms. And so we're gonna have two platforms, and then we're gonna have one platform that's moving in between those, and then we'll make it so our character can step on that and go in between those two. So we're gonna use this one as a platform. So let's make it platform 1. We gotta make sure it's anchored, and then let's give it a cool color. Something. I want red. You know, color is important. We don't need to worry about color. Alright, color is important. Let's do... Alright, I'm just gonna do this cool green color right there. So we're gonna put this one right here. Alright, let's get rid of that ugly motor thing. There, let's make it 5, 1, 5. That's too small. We're gonna do 10, 1, 10. 10, 1, 10. There you go. And we're also gonna put a spawn point on there, so that way when the character spawns, we'll actually be able to get up there. There. And let's make it invisible. So let's get rid of that. So and then we'll make it turn off can collide, so it doesn't interfere with anything. There we go. So now let's make the other platform. Or make it straight across like that. We're gonna do platform 2. Now let's get the moving platform, which is gonna be unanchored, and let's make it that nice color. And we're gonna name it moving platform. There. It's important to name your parts, otherwise later when you need to script things for it can be very difficult. So, oh yeah, so we also need to make sure this one is can collide. Alright, that one, okay, can collide is true for that one. There, so what we need to do is we need to put a body gyro in this one, because once the player steps on it, it's going to start spinning all over the place. So body gyro, and we need to make the max torque on all of these. math.huge, so we can use the command bar for this one. Oops. So we can, never mind. I also do the command bar for this one. So we're gonna do workspace dot body gyro dot max torque equals vector3 dot new math dot huge enter. Oh, whoops, Stevie. You gotta talk about the part we're using. So workspace dot moving platform dot, there we go. So now if you look in there you go, max torque is infinite. So we're okay with that. You can delete that part in the command bar now. So now I think that we should make it start off right there, and then we should use, let's use body force. Actually no, let's use body velocity, then we won't have to worry about finding huge enough numbers to make it work. So I'm going to use body velocity for this. Alright, so since this is on the x-axis, we only got to move it on the x-axis. So I'm going to keep that at 0. And then let's get a script. So first we got to set the max force. So script.parent.max force equals vector3.new math.huge. We're going to keep aggressiveness the same. And so now we just got to have we have to alternate between the velocity when it gets to the other part. So let's see. So this position is -14 on the x-axis, and this one is 51.2. So let's try to do some math here. Print. So we got to find out how long we need to make the velocity go in that certain direction. Before we got to change it again. I'm not exactly sure how these velocity stuff works. Like what is the speed is measured in. I'm not sure if it's like studs per second or something. But we're gonna assume for now that it's studs per second. So right now the other one is 51.2. We're gonna find the difference between the two. So minus 14. I know it's not how you're supposed to do it, but I'm not a big math person. So 65.2. So that's the difference between them. So let's see. 65. Here, we'll just figure it out as we go along. So what we're gonna do is that we're going to put this in a while loop. We're just gonna keep repeating this. So while true. We don't need to have a weight between each of these because there'll be weights inside of these. So we're going to do script.parent.velocity equals vector3.new. We'll need to work it on the x-axis. So we're going to do, let's see, 5. We're going to make it go 5. And then we're going to weight, so 65.2 divided by 5, so take about 13.04 seconds. Alright, let's speed that up. Let's do 15. I want to wait 30 seconds to see if that works. I mean 13. 5. Alright, so about 4 seconds. So let's just copy that there, because it's kind of a big number. Then okay, let's do 4.35. That's what we're going to do. And then we're going to do script.parent.velocity equals vector3.new -15. So it's going the other direction now. So now I think this should work. Let's see what it does. Oh, I think I was right. Why aren't you moving? Oh, I know why. Oops. Alright, so what happened here is, so this loop is repeating itself over and over again. So what it's doing is it's changing the velocity of 15, and then after that it's changing to -15. But then the loop ends, and so since there's no weight right here, it automatically goes back to the beginning, so it automatically becomes regular 15 again. So we need to have this weight again right here. So 4.35. So let's do run again. So now that should work. Oh no, I was wrong. Oh well, we just need to increase it a bit. So we need to start to increase the speeds. Let's try 20. Let's press run. Oh, look at that. Let's try 25. And let's have, I actually think we should have a weight between each of them, because then the person will have no time to get on the platform. Let's do like weight 3. So now let's press play and see if we can get on it. Hey, what's up with the spawn point? Didn't work. Let's try this again. Oh, oops, I accidentally disabled that. There we go. Alright, get on. Oh no, I missed it. Reset the character. Hurry up. Yes, I'm on. Oh no. Oh yeah, look at that. It works. Oh no. Bumped me off. You wait for the next ride. So good thing Roblox updated its physics, because this stuff used to not work. Oh dang it. Before, like if you tried to do this with old Roblox physics, then your character would have just like slipped off the whole thing. You wouldn't have been able to stay on. But Roblox thankfully fixed this in its newer physics, because they're doing a pretty good job. What happened? Oh no, it changed how high it was going because it got bumped around so much. Oh well. Well, so that's pretty much it, guys. I hope you guys learned something about these body movers. So that is all the body movers that there are in Roblox. So that concludes the body movers section of these tutorials. If you guys learned something or enjoyed this, please subscribe and thumbs up, and please tell your friends about this channel too. So I'll see you guys later.